1995, a wildlife biologist opened a metal crate in the middle of Yellowstone National Park. Inside was a gray wolf, sedated, breathing slow. For 70 years, there had not been a single wolf in this park. Not one. And what happened in the years after that crate opened did not just bring back an animal. It rearranged the rivers. To understand how a wolf can touch a river, you have to go back to 1926, the year the last wolf in Yellowstone was shot. At the time, nobody saw this as a loss. Wolves were considered a problem to be solved, a threat to livestock and to the elk that visitors came to see. The park itself paid hunters to remove them. By the late 1920s, the job was done. Yellowstone was wolf-free, and for almost 70 years, that was treated as a success. With no wolves left, the elk population had nothing seriously hunting it. Their numbers climbed and climbed and kept climbing. Thousands of elk spread across the valleys, and they ate constantly, especially along the riverbanks where the young willow and aspen trees were easiest to reach. Over the decades, those riverbank trees stopped growing back. Saplings got eaten before they had a chance to mature. Without root systems holding the soil, riverbanks began to erode. Streams that once curved and pooled started running straighter, faster, shallower. Beavers, who depend on willow to build dams, left the rivers because there was no longer enough material to build with. Without beaver dams, the wetlands that used to sit behind them dried out. Birds that nested in dense willow thickets disappeared with the willow. None of this looked like one disaster. It looked like dozens of small, disconnected changes, and for decades, nobody connected them to the missing wolves. By the 1990s, scientists studying the park's ecology started asking a different question. What if the wolves weren't just absent? What if their absence was the actual cause of all of it? In 1995, after years of legal and political battles, 14 gray wolves were captured in Canada and released into Yellowstone. 17 more followed the next year. Biologists tracked them constantly, expecting a slow, modest recovery of a single species. What they got instead was something closer to a chain reaction. The wolves began hunting elk again, but the bigger change wasn't how many elk died. It was how the survivors behaved. Elk stopped lingering in open river valleys where wolves could spot them easily. They moved more, grazed more cautiously, and avoided the exposed riverbanks they used to graze on for hours at a time. With elk pressure removed from those specific areas, willow and aspen saplings that had been eaten down for 70 years finally got the chance to grow past a few inches tall. Within several years, willow stands along certain streams had grown 5 times taller than before. Beavers started returning to rivers they had abandoned decades earlier because there was finally enough willow to build with again. Each new beaver dam created a pond. Each pond slowed the water down, spread it out, and recharged groundwater nearby. Fish found new cold, slow-moving pools to live in. Amphibians that need standing water to breed started showing up in places they hadn't been recorded in years. Songbirds that nest specifically in tall willow returned to stretches of river where they'd been absent since the elk boom began. Scientists studying the rivers themselves found something stranger still. Streams that had been eroding into wide, shallow channels for decades began narrowing and deepening again as plant roots stabilized the banks. The physical shape of the rivers was changing, measurably, because of an animal that never once touched the water. Not every scientist agrees on how much credit the wolves deserve. Some researchers point out that a series of wetter years coincided with the wolves' return, which also would have helped willow growth independently. Others argue that human hunting restrictions on elk played a larger role than the wolves themselves. The honest answer is that it's difficult to isolate one cause in a system this interconnected, and the scientists who study Yellowstone most closely tend to describe it as multiple factors reinforcing each other rather than wolves acting alone. But even the skeptics agree on one thing. Removing a single predator in 1926 set off changes that took 70 years to fully reveal themselves, and nobody initially saw it coming. What happened in Yellowstone has a name now. Ecologists call it a trophic cascade. When a change at the top of a food chain works its way all the way down to the rivers, the insects, the soil itself, But the more useful lesson might be a simpler one. Nobody in 1926 thought shooting the last wolf would change where a river ran. It didn't look connected. It looked like managing a problem. The wolf and the river had no obvious relationship, until one was gone long enough for the other to fall apart quietly, one small piece at a time. We are usually better at noticing what we add to a system than what we remove from it. Yellowstone spent 70 years finding out what a single missing predator actually costs. The wolves came back in a crate in 1995. The rivers are still responding.